let's review what we've learned about valence bond theory. And we're going to give this review by steric number. Sn2 geometry is this one here. And a very convenient way then of drawing orbitals for that is we put one sp hybrid to the left, one sp hybrid to the right. We have two remaining p orbitals, which right now I'll put here and here. And this is sp2 plus p hybridization. We could, if we wanted to, change the direction of the sp hybrids. So let's just change the direction of sp, just rotate the picture. Let's change it so that one sp hybrid is pointing up and the other one is pointing down. So we're just rotating our picture. Put in chat, where would the two remaining p orbitals be? Would there be a p orbital now pointing up and down? Put in chat, would there be a p orbital pointing up and down? No, because those are the sp hybrids. The p orbitals will there be a p orbital pointing sideways? Yes, there it is. And where, put in chat, is the direction of the remaining p orbital. Coming in or out, up or down, left or right, put it in chat. Up, left or right, out or in, and the answer is out or in. So I'll draw like this. And I'm going to draw, because it's steric number 6, the octahedron. And we now have two sp hybrids pointing along two directions of the bonds. But we have two p orbitals pointing along the remaining directions of steric number 6. Let's move to a new picture, a color. Let's do this in purple. Steric number 3, which is shown here. So we saw that the sp2 hybrids are one in this direction, one in this direction, and one in this direction. Put in chat what the remaining direction is. The answer is the p orbital coming straight out. That's sp2 plus p. But we can also consider the other trigonal plane in steric number 5. The equilateral triangle in steric number 5, is it axial or equatorial? Put it in chat. The trigonal plane in steric number 5, is it axial or equatorial? It is equatorial. And so in the direction of the trigonal plane, I draw my sp2 hybrids. And here it is coming out, coming back. And the remaining p orbital is in the direction perpendicular to that. Put in chat, axial or equatorial, remaining p orbital perpendicular to the directions of the equator. It makes it axial. I draw it here. And all just is change the direction of the bonds to suit the ordinary way we look at steric number 5. The last geometry is steric number 4, which is a tetrahedron. And I'm not going to show you the mixing that created it, but Linus Pauling figured out a mixing scheme where the 4 orbitals point in the directions of the tetrahedron. So all orbitals mixed, there are no longer pure p orbitals, all in the four directions of the tetrahedron. There are no p orbitals, they're all some kind of combination s and p. They're called sp3. So those are sp3 hybrids. And these then are valence bond hybridization schemes.